Okay, 37, mean value theorem. F of x equals x log of x. Here's what the mean value theorem says. If f of x equals x log of x is continuous on a closed interval a to b, differentiable on the open interval a to b, because we don't worry about the endpoints being differentiable because they'd be one-sided derivatives. Then there is some c in the interval such that the derivative f prime of c is equal to the average rate of change. And you should kind of have an idea of, okay, what does that look like graphically? Well, graphically, that just says here's A, here's B. Whatever this curve might look like, as long as it's continuous and differentiable, although it's got to be a function, right? That there's some C. Here's the average rate of change. That's the slope of that secant line, right? That's f of b minus f of a over b minus a. That's the slope of that. Somewhere there's a C where the derivative is exactly parallel to it. That's the mean value theorem. So A simply asks you, excuse me, to show that f satisfies the hypothesis of the mean value theorem on the interval 1/2, 0.5 to 3. Okay, well, f is continuous on 0.53, since y equals x and y equals natural log of x are. Both of those functions are continuous, so when you multiply them together, the product will be. Okay, and same thing with the derivative. Since f is differentiable, or not since f is differentiable on the open interval 0.53, since y equals x and y equals natural log of x are. The only time you have to really worry about when it's not differentiable or continuous is when one of the functions doesn't exist at those, somewhere there. Like if this went over 0, you can't take the log of 0, so the product isn't going to be differentiable or continuous there. So hypothesis done. So we're good there. So B. I can move this. I'm going to move this down here, or maybe not. Can't grab it. Oh, well, let me move it for some reason. Okay. B. Find the values of C for which f prime of C is equal to f of b minus f of a. Okay. So f of b minus f of a, this is b over here. So it's f of 3 minus f of 0.5 over 3 minus 0.5. So we're going to have to figure that out. And then figure out what is f prime of c and set them equal to each other. Okay, so I'm going to have to go grab a calculator. Oops, okay, here we go. So I went ahead and did that on my calculator, got that. Please do not round this off even to 3 decimal places yet, because when we go to do the calculations, it'll mess up our final answer. So I've got this. I've got to find f prime of c. F prime of c, well, f of x is x log of x. So let's look at f prime of x first. Let's do it this way. Is first derivative second plus second times the derivative first, which is 1 plus natural log of x. So f prime of c is 1 plus natural log of c, and that's equal to 1.456964. Solve for c. Natural log of c is 0.456964. and so then c would be e to the 0.45694. And I just left the whole number in my calculator, and I'm just going to go e to that power. E. Sure. Oops. I guess I got to. Oops. I forgot to subtract the 1. Let's do this here. Okay, and if you do that, you get 1.579. Oops. Okay, if you round this off to 3 decimal places, and then you do e to that power, just so you can see this, and we'll talk about this in class quite a bit, e to the 0.456, you would have gotten 1.577, and you would have gotten that wrong. You've missed a point on the AP test for that, and that's kind of a silly thing to lose a point for. So be careful, very careful not to do that. Okay, so that's part B. And then C, write an equation for the tangent line that's parallel. So we actually want to write the tangent line. So I know this is C, and I know what the slope is. This is the slope. Right, so here's my tangent line. Here's the slope of the tangent line. Here's the, this is the C, the x coordinate of my tangent line. This is the slope of the tangent line, right? F of b minus f of a over b minus a. And so now I just have to find the y coordinate. And to find the y coordinate, that would be f of 1.579. And I'm actually just going to leave that in my calculator as well. So it'll be that number times the natural log of that number. And I get 0.719. So the tangent line is going to be y minus 0.719 equals the slope 1.457 times x minus 1.579. So there's the equation of the secant line. Oops, oh, that's the equation of the tangent line. What did they ask for? Equation for the tangent line. Oh, let me go back up here. Yeah, equation for the tangent line parallel to the secant line. So yeah, that's right. That is the tangent line that's parallel to the secant line. There you have it.